All right, this is to accompany Chapter 18, talking about human influences on climate. There's not that many slides here, but there's a lot of parts to the slide, so it's going to take a little while to go through. First, climate is shaped by three major factors: the sun, the oceans, which can store heat, carbon dioxide, they evaporate water to distribute water throughout the atmosphere, and then the greenhouse gases. These gases warm the Earth's lower atmosphere and surface. They reduce the amount of heat leaving the atmosphere at night. Okay. Human influence on the atmosphere has affected the composition of gases in the atmosphere. The primary gas is nitrogen, then oxygen, argon, and then you have trace amounts of carbon dioxide, ozone, methane, water vapor. Um, Atmospheric composition is dynamic. There is exchange of gases with the ocean and the soil and living organisms. And we've done a lot to change this. We've burned fossil fuels. That's coal, oil, natural gas, jet fuels, things like that. And that annually adds lots of carbon dioxide to the atmosphere. And so we've measured changes in carbon dioxide in the atmosphere. These are measured at Mauna Loa in Hawaii annually, and we can have records of this going back almost 200 years. And so then we know that there's really only been three times where the CO2 concentration hasn't increased: World War I, the Great Depression, and World War II. When it goes back past about 70 years, then we rely on data from the past that's reconstructed. And to do this, we looked at air that's trapped in ice cores. And so we go to glaciers or to the poles, and we drill these cores and then pull out the gases that are trapped in the ice. From this, we can determine greenhouse gas concentrations. We can identify when these gases were there by looking at things like annual layers of snow, traces of volcanic eruptions, forest fire activity, and we can correlate these with measures of temperature based on isotope concentrations in the atmosphere. So we know that CO2 concentration corresponds to temperature. Periods of low CO2 correspond to periods of lower temperature, and high CO2 corresponds to higher temperature. And during the 19th and 20th centuries, concentration of CO2 was rising dramatically. Okay, so this is the key point here, is that there is dramatic evidence that the climate is changing. And so, and this is multiple lines of evidence. And so let's go over this evidence and then we'll talk about it. First is that the temperature of the oceans and ocean pH are measurably changing in the last 100 years. This is a huge body of water, but we can actually measure changes in the amount of heat that it stores and in pH, which means that the dissolved oxygen concentration is rising, and so the pH of the ocean is falling. We've also can measure quite carefully sea level increases. And of course, we have good measurements of sea level increases going back to the 1700s because navies around the world, harbors around the world were measuring sea level. Okay, we also have good measurements for about, I don't know, 70 years of polar ice. These are satellite and aerial photos. We can measure that ice is decreasing in area and in volume. We also have good evidence of decreasing ice in glaciers, mountain glaciers on the continents. We also have good measurements of permafrost changes in soil temperature, and in the distribution of organisms, which we could call biological indicators. Okay. One of the weakest indicators of change is the changing air temperatures, but there is evidence that air temperature is changing, but that's pretty variable. Water temperatures are much more stable, and all these other indicators work together. And that's kind of what I want to talk about. When you look at the press and mass media, they often focus on weather. And weather is generally refers to day-to-day temperature and precipitation activities in a local area. Um, it's highly variable, whereas climate is the long-term patterns and variation in temperature, wind, humidity, pressure, and precipitation over a long period of time. Climate is not weather. Okay, there's differences. Climate change can still mean that weather is variable, even though that it may be very cold today. Overall, climate can be warming. Okay, the best pieces of evidence are pieces of evidence that are really consistent, like rising sea levels. Change in average sea level over the past 200 years is really good evidence. We have nice evidence from sedimentary cores of where sea level was previously. We also have very good measurements going back a long way that show us, oh yeah, global sea levels are rising and it's a consistent rise. That's a really, really strong piece of evidence. And this is due to thermal expansion of water as it warms and melting ice. Okay. Another really strong piece of evidence is looking at Arctic sea ice. Okay. Arctic sea ice has been measured uh, really closely because of military's use of submarines going underneath there and satellite imagery. And Arctic sea ice has been decreasing dramatically during that time. Um, the average area covered by sea ice has dropped by half. The volume of the sea ice is dropped by 2/3. Okay. Other really strong pieces of evidence of warming have to do with uh, glaciers. These are ice on mountains in terrestrial areas, and this graph just shows North America, but it shows that 95% of North American glaciers are losing the volume of ice. And so some of these glaciers you might have heard of, like the Columbia Glacier, which I'll show you a picture of that. And so parks like Glacier National Park probably have to change the name because glaciers are shrinking dramatically. Okay. Um, Another type of evidence that's really good is the decrease in soil temperatures, or an increase in soil temperatures and a decrease in permafrost in Alaska. This is really important because lots of buildings and roads are built with the idea that the ground is permanently frozen, and that's not true anymore. And so places you used to be able to go by driving on frozen ground, you can't get anymore. And so this is another really strong piece of evidence, and we've got good measurements. Okay, so that when they first kind of realized that carbon dioxide was the most abundant greenhouse gas and carbon dioxide levels were increasing, they began to make predictions that there will be um, this will cause a retention of heat, and that retention of heat will cause increased ocean evaporation because evaporation is temperature dependent. This means we'll have prolonged heat waves and possibly prolonged droughts because you'll have evaporation from terrestrial areas. Okay, but because you're also having evaporation from the oceans, there'll be prolonged heavy rains and flooding. So we'll get both of those things at the same time. We'll also see changed weather patterns. Um, Storms are due to evaporation and the accumulation of moisture in the atmosphere. Okay, now the atmosphere can hold more moisture, and evaporation over the oceans will increase, so storm frequency and intensity will increase. There'll be changed seasonal patterns. Ocean currents and wind patterns may change. A good example of that was in 2014. We had one of our coldest winters in a long time because an area of cold air that's normally confined over the pole slipped down over North America. This is called the polar vortex. Okay, and so we're already seeing some of these things, and these things are going to have big effects on humans. It's likely that this will cause agricultural productivity to decrease because of prolonged heat waves and droughts, and because of the prolonged heavy rains and flooding. Agriculture plants need a steady amount of rain and moisture and sunlight. There'll also be an increase in pest species and disrupted climate patterns. Another source of food, seafood, fish fish and shellfish production will likely decrease because river deltas will change and be flooded more often. The oceans are becoming more acidic, and so that makes it hard for shellfish and regular fish to get the minerals they need, and decreased nutrient supply. Global warming will also increase human deaths from things like heat, flooding, disruption of food, and spread of tropical disease until temperate regions, and then increased conflict and refugees because of the environment. Okay, and if you read about the Syrian conflict in Syria recently, that's largely a drought-based conflict. Okay, so in summary, reliable climate and ocean measurements extend from the 1700s. Evidence from glaciers, sediments, and chemistry of ocean and the atmosphere all indicate a link between temperature, sea levels, and greenhouse gases. Multiple lines of evidence indicate greenhouse gases are changing climate and sea level. Predicted effects of the changes in greenhouse gases are occurring. Okay, and generally there's a scientific consensus about this. I'll have a little bit more to say, but the main point is that humans can affect the climate. Human activity affects the physical environment that we're in, and that has a feedback effect on us.